Thanks, guys.
I'd like to welcome everybody who's coming on today. We have a little Zoom housekeeping. Today, you're going to be muted, but I encourage everybody to ask questions. You can do it in chat. You're welcome to do it on Q&A. And where we have a break, I will bring in the questions so that Gary can answer them. So welcome, everybody. And I'd like to go ahead and introduce Gary as everybody is coming in. Gary Brach is part of Phase Change, and he is in AI, and it is a software that is quite frankly amazing. I spent most of last night reading up on it. He's had a long history, which I'm sure he'll share with you a little bit. They're quite far along in their fundraising, and I find it fascinating. So Gary, I'm going to let you go ahead and start in and mute out, and please take it away.
Great, thanks, Wendy. Can you hear me, Wendy, and everyone?
Absolutely, you're good to go.
Great, thank you. Hi, everyone. As Wendy said, my name is Gary Brach, and I'm the CEO of Phase Change. I got involved with Phase Change a number of years ago as an investor. And I've been an entrepreneur in the software industry for about 30 years. Had four companies that I started and sold in fintech and in the storage software space. One of the issues that I've always experienced in every single company that I've been involved with, and also dealing with larger companies, has been the issue of why does it take so long to develop software? Why does it take so long to change software? What, simple things that are small changes seem to take forever. And there's a reason for that, and it's because we don't know how software actually works that well. It takes a long time for humans to figure out and read software and build a conceptual framework and also be able to remember everything. So when I looked at this company as a potential investor and met the team involved, I was really interested because I have experienced this problem, for the past 30 plus years, again in my career, and it's just I think an extremely exciting opportunity to really transform how software is developed going forward. As Wendy said, we're creating artificial intelligence software that understands software. And so the idea is that we're going to make software developers more productive than they are today, and significantly more productive than they are today. And that's really the problem. The problem is that these companies, if you're at Chase Manhattan Bank or a large company, you have these large systems that were written a long time ago, and they're in some cases hundreds of millions of lines of code. They're mission critical, they're complex, and you need to change this in order to be able to compete with the more nimble fintech startup that's out there. And it's really, really difficult and really expensive to do that. So companies today in that sort of box, these larger companies are spending about 70% of their time, 70% of their time and 70% of their budget on maintaining and fixing their applications. And the reason for that is when I have to go fix a problem, I have to understand how a problem manifests itself. And so Microsoft did some research a number of years ago, and the research indicated that developers spend 80% of their time trying to understand how the code works, and only about 20% of the time actually coding. And this equates to about a cost of about 5 lines of code per hour being developed, and at $10 per line of code. So it's very expensive process. Furthermore, as you get into some of the systems that have, some of these legacy systems that are written in older programming languages, in particular, there's a significant knowledge gap as these the people that wrote the systems and understand the systems have retired or have left the company. As an example, if you look at this at the bottom of the screen, you can see this is one of our beta customers. Their application understanding in 2006, the green designates what they know, the yellow designates what they're not sure of, and the red shows what they don't know. And as the application has grown over time, and people have left, there's a double whammy, which is that they have now a system that is fragile, and that the knowledge loss as they've experienced really makes their system much less reliable and much more difficult to change. And this is a systemic problem in software. Once software is built, it's really, the next day it's almost legacy. I mean, as you have churn of people, and there's a tremendous amount of movement as far as people moving within the software industry. So knowledge loss is the key. And there's a significant knowledge gap, and that's really what our technology is solving. What our technology does simply is it reads in software, it analyzes the software, digitizes it into a proprietary format. That proprietary format we have 4 patents on that we received, and what we're focusing on is just the behavior of the software. And so we have, in essence, the first time software has been digitized into a behavioral model. And then we have an assistant that understands the system just like a human does. So the AI that we're deploying is, there are 2 different types of AI, but the second AI is more, is a cognitive understanding. So it does thinking in sort of short term, thinking in long term, being able to deliberate, being able to dissociate, so that in essence, what the user gets, the user asks it a question and says, I want to find, for instance, let's say I have a negative account balance. I want to find where in the software I can logically, what can create a negative account balance? And it would go and find that for you instantly. Instead of spending hours trying to figure it out and not being sure if you've tracked it all down, our software is precise and fast. It would tell you immediately. So the initial application that we're focusing on are large systems. The first programming language that we're focusing on is Cobalt, because this is where the biggest knowledge gap exists. These are large systems and incredibly rigid. Our technology, however, is extensible to all programming languages. We're just focusing on Cobalt first. We're focusing on the area of being able to query the software to be able to find information, which helps with changing software, maintaining software, and modernizing software. So for instance, I want to modernize software. I want to change it to be more compliant on the cloud. We would be able to do the analysis part to help you do that. We don't do the actual modernization. We don't change the software in any way, but we tell you how the software operates, which makes it much easier. From a competitive standpoint, this is a new category. There are tools that are out in the marketplace today that provide an analysis of how the software works. And they're prevalent tools that people use on a daily basis. What they don't tell you, however, they don't interpret the software and communicate how the software, they don't answer questions for you. They give you sort of a blueprint or give you an idea of how things work. Our technology is a significant gap from that, and it tells you and isolates exactly where it is. Problem is, you ask it questions, it comes back just like a human would. And so when we look at the map of and as we talk to Gartner, people like that, we look at the map of category of cognitive, what we call cognitive automation. This is the first product in that category. Now that's a good thing and a bad thing. It's a good thing because there's significant moat, but it is a new category. So it takes people a while for them to understand and get their heads around what it is we're actually doing. You have to sort of see it to believe it. As we look at the addressable market for just Cobalt, it is a $4.6 billion addressable market. There are 2,300 companies running large Cobalt systems. These systems have, on average, a little over 100 million lines of code per system. We will be able to, our model for selling this is a subscription model. We believe in time we will be able to generate $2 million per customer. We won't be able to generate that initially, but we'll be able to ramp up to that as we offer more capability, more cognitive capability. And so there's, again, a $4.6 billion market opportunity. And just in our first foray, which is Cobalt. And as you can see, that's designated in the slide. So this is just the Cobalt market. There's obviously other languages, Java, C, C++, Python, so forth and so on. Our technology is really applicable to large, complex systems. So it's not applicable to like little apps that are out there, but larger systems where there's complexity and it's hard for humans to understand all that's going on. Again, we have sort of two areas of product growth, other languages, which I mentioned, and then up the cognitive stack. So again, today we're focusing on sort of managing change outcomes and reasoning, but eventually we could be helping with assistive predictive coding. So for instance, the way to think about that is I am a developer and I want to find an algorithm that writes a reverse mortgage, for instance, or does a hashing algorithm or something to that effect. Today, the way you do that in the open source world is you go and you look at open source and you have to go look at the software, understand it, or you go by what somebody says about it. What we're talking about is understanding the behavior of the software we've analyzed it. So we've analyzed it. We understand exactly how it works. So you can ask the system questions. Say, I want to find a hashing algorithm that is optimized for persistence, for storage, and it would go find that for you. So the assistive predictive coding area is really taking the patterns that exist in software today and reapplying them and reusing them as I code going forward. So initially, again, we're focusing on sort of the standard day-to-day meat and potatoes of managing a system, but in time, this will move up to really every task. And what we're really trying to do is make every software development task more efficient. And we can do that with additional money, but we can do that because we have digitized software for the first time. So if you think about what you can do with pictures and how you can scan pictures and sort pictures based upon things. And we're really talking about the same thing. It's just that software has never been digitized like this before. Data, you go back 20 years ago, 30 years ago, images or data was digitized, and you can do a Google search. There's no reason you can't do the same thing with software, and that's really what we're talking about. It's really a significant breakthrough in the way people work today, and as a result, people will be significantly more productive. We're currently working with 3 large financial services firms. We did an alpha with the Depository Trust Clearing Corporation, who they paid for a proof of concept that we completed last year. They're the company that clears all trades on Wall Street, have a massive system that needs to change. It needs to be modified all the time. And they're one of our 3 beta clients that we're working with. We expect our customer shipment to be at the end of 2021. We expect that customers will they'll try this for a smaller subset of their software, and then it'll grow as time goes on. So we expect sort of trials at $250K per, just begin with, and then that again expanding out to about $2 million as they expand it out to their entire application. We expect to attain with money raised, cash by the end of 2022. I'm sorry, with money raised, expect to get to break even, and initial sales will be sold directly and through mostly Cobalt sales channels. The company's raised about $35 million to date through friends and family. We're very close to the finish line. We're really at this point looking for additional investors to help, to add to the folks, as we had some folks who are obviously tired of this, but the investor base is very, very solid. We're looking to add additional investors to get us really to beyond product and into profitability, and then into future development of these other programming languages and other capabilities.
Gary,
Yes.
so we have a question from the audience. So it's, does AI work on Solidity, and how many lines of code were used to train your AI?
So it's a good question. So we are, I don't know how deep to go. I'd be happy to take that question offline, but the way to think about it is we read the software and create a symbolic representation from the software. So it's a different methodology than your classic machine learning, where you have to get a bunch of different data all over the place and you learn that way. We actually create a rules-based symbolic representation of the software. So we take whatever software is there and then we we analyze it. So our issue is making sure that we create all the appropriate rules to support the language. And that's the last piece that we're working on. So for instance, Cobalt has about 100 keywords, 100 different commands, but they semantically can work differently. And so we have to, we trap all those different ways that they operate and create rules around that. So our AI is initially more of a symbolic AI than it is, your classic neural network type of AI. I hope that answers the question. I'd be happy to go into more depth offline, but that's how we do it.
Thank you so much. And Gundren, just reach out if you need more. Arthur, I'd be happy to connect you. We have another question, which is, what's your pre-money valuation and how can we get in touch with you for investment purposes?
So I can be, well, after this, I will get in touch with everybody, but I can be reached at gbrock@phasechange.ai. Or we, through this conference. Our pre-money valuation, the last round that we did was at, there was a sort of a hybrid note. I don't want to go into too much detail, but it was under $20 million. I think that this round will be around, $20 to $25 million. We're working, all the other rounds that we've done have been price rounds. This round, we are talking to some people overseas, and so it would most likely be a round, they price it and set the terms. And so, but my expectation is that it's somewhere in that range, 20 to $25 million. Now, look, we've invested much more than that in the product. So we've invested about $35 million to date. So, but we understand that, we don't have a product out in the market yet. And, we have to be rational about kind of where we are and so forth. We do believe that the inflection of value will be significant. Number one, when we get to market, because people will be amazed that this is actually possible. Obviously, as we generate revenue, but even more importantly, as we generate additional, take this technology and make it available for other programming languages, and people see the entire vision of what this can become, we believe the value is immense going forward.
Hey, Gary.
Yes.
Since we're on the topic of business and revenue, if your pilot is, or your beta is 250 and then 2 million is the engagement, and I know there's probably all kinds of variables in there, but if you had to just sort of predict, do you need 10 customers, 20 customers in the next 24 months to become cash flow positive, as you say, in 2022? Maybe I'm getting the dates
Yeah,
wrong.
no, that's a great question. So our conservative model is, our model is assuming that people are going to take a smaller bite size. So we have, our model says that we would have 19 customers, we'll get to break even. That does not assume any, significant increase in spend over that, over that first year. So, and so that's our assumption. Some indications are that that's actually not correct, that people are going to spend more. At the very beginning, they want their entire application under it. And so, in that case, it could be as little as 3 customers, right? To get to roughly our run rate right now is about $6 million. So to get to break even, it could be as little as 3 customers. We have in our model 19 customers. And so it's somewhere in between, I would suspect. Now, the way we get to 19 customers is there are people in the market that's focused on this Cobalt market, and IBM, CompuWare, which is BMC, Broadcom are the 3 major guys, as well as the professional services firms. Those are those will be our entree into those folks will be their entree into the market.
So traditionally, and I'm wondering whether this is still true, the big accounting firms, which are the professional service firms I think you're referring to, are the ones that are hired to find the solutions to the problems. Is that still the business development methodology in large part?
Yes and no. That used to definitely be the way that, and they do it to some extent today. I think that in the Cobalt space anyway, it's really the IBMs and the folks that I mentioned, the Infosys's and people like that bring some of the stuff. Now that being said, we are talking to folks like Price Waterhouse because our technology is applicable to governance, and governance that's an area where they become, they're not as big in the sort of the software development arena as they are in the processes around software development. And so we have had some pretty significant conversations with folks at those firms, and that's where they will be helpful. Now, there'll need to be some modification made to our technology, not a lot, but we view governance as an area of opportunity, and those folks would definitely bring us in too. And we've had, again, meetings with the senior folks at Accenture and Price Waterhouse and people like that. So it's a good question though. Are there any other, before I get into the team and any other questions that you're seeing, Arthur or Wendy?
Hey, Gary. So we're being asked, can you please shed some further light on your methodology mentioned before?
Sure. So the way that I'm assuming that's the technology and how the technology works. Is that the?
Yes.
Yes. So what we do is we take software and we compile it. We basically compile it into a raw form, and then build it back up into a behavioral model that understands the dependency, order, and behavior of software and how it works. So it basically maps that's what's digitized. That data, that set of information is complicated, but it is digitized. So that's where our secret sauce is. Then we apply techniques on that software to reason on it. So we use technologies like Prolog. We use technologies like JS, the JSM, the Java, JVM, excuse me, to then reason on it. So, what we need to do in the next step is understand the logic. We then, in its first order logic, we then provide techniques to be able to then navigate through the software. So you're using math like Horn's clause, and you're using least models, and you're using all kinds of advanced techniques to be able to work your way through the data set. The architecture of the technologies, we actually don't do all of the building of that data set at the very beginning, because it's too big. We actually break it up into conceptual maps that are manageable, and then as the user works his or her way through the series of questions, information is cached and brought up and then explored through our assistant. So the components are a compiling technology that builds a data set, a reasoning engine that logically understands how that works and can manipulate it, and then an assistant that interfaces with the user to enable the user to manipulate the information, to ask questions and be able to work the data, work the information. So for instance, again, the user might say, I'm getting a negative account balance. The system would say, what file is giving you the negative account balance? Or it would guide them through the scenario to the point where, as they work through the system, it's going and hitting all the different areas, bringing up the relevant information, focusing on the area of interest, and providing the data, the actual tied back to the source code that is where the logic occurred. So there are many, many pieces. It's actually complicated. So our folks and our team are, a PhD in logic. We have folks that have PhD in program analysis. Folks that they're all very smart mathematically, but they're again different areas of expertise, because it's a multidisciplinary problem.
So Gary, we have a question asking if you've received any pushback from Accenture.
Pushback from Accenture?
Yes.
When they say pushback, meaning, I'm not sure what that means, meaning that they are not interested, or?
Well, we can't interpret for.
I can tell you what, we talked to Accenture seriously about a year and a half ago. They're extremely interested in what we're doing. We talked to the head of their AI group and head of their financial services group. They evaluated our technology. We're evaluating our technology, thought it was too early for them to make an investment at the time. That's what I can tell you. So if that's pushback, that was pushback, but they're extremely interested in what we're doing.
Fantastic. And we have another question. If it's not general AI, what is it?
Yeah, it's a good question. It's really applied AI. It's symbolic. The way to think about it is it's symbolic AI, and it is akin to the old expert systems. It's more akin to Watson than it is to the Google, other products that are on the market. I mean, it's more of expert system-like. Now, that being said, it does use some machine learning for pattern recognition. So once we create the structure of the data, we're looking for patterns, just like machine learning is looking for patterns. So, but the core of the technology is symbolic. So it's an applied AI. It's applied strictly to software. That's our domain.
So back to Accenture, what the attendee was asking is, what objections did they raise with what your software does or does not do?
The question, it was not mature enough to go to market. That was
Fair
our only objection.
Fair enough. And another question is, what is your accuracy and how are you determining that percent?
Our accuracy is 100%. And that's why it's, again, the difference between symbolic and standard neural networking approaches. We are not approximating everything. We are creating the rules that define exactly and precisely how the software works. That's our competitive advantage. There are technologies we're sure that will come out in the future that will use neural networks to do some of the stuff. They will never, they will not be as precise. For somebody to be as precise, you have to go, you have to be, go down the symbolic route. You have to create the rules that define precisely how the software works. So in a way, and we debate this all the time, using the term AI is somewhat misleading. It's not in the truest sense, because what symbolic AI is AI. But when people think about AI, they think about the idea of approximation. This is not approximation. It is the old school AI that is symbolic. So we create, so in the case of Cobalt, for instance, there are things like loops and go-tos and things like that. We create the methodology to understand exactly how that works. There's no prediction of how that works.
So another question, and really appreciate you taking all the questions. Another question that we have here is, are you training AI to write new AIs?
That's a really good question. I mean, yeah, we eventually, one of the problems with AI is that we don't understand how the AI got to its answer. It's a systemic problem with AI. It is possible that this technology, with modification and significant modification, could describe why the answer is the answer. In other words, what created the AI? So that's one example. But we're not necessarily creating an AI. We are creating, our domain is software. What we're really doing is extracting the knowledge from software, so that humans don't have to spend their time extracting that knowledge. We could conceivably write software for people, but it would be based upon past patterns. It doesn't just won't magically create software. There are some techniques that people are using to create software. They're very rudimentary, but big guy, Microsoft is looking at it, Google and Apple are looking at that type of thing. We're really focusing on the understanding of software, the digitization of software, and then leveraging that going forward.
Fantastic. Our next question is, when it comes to predictive analytics, how does your software work?
We are not in the predictive analytics space at all. We are in the software space. So that's really not a space that we participate in. But again, that's what people think of when they think of AI. We're focusing on the logic around software. So that's our domain. Just like you build up a predictive analytics systems can, they build domain knowledge through data being brought into it. Our domain is strictly software. And we understand how software operates before the software gets into our system. All we're doing is then presenting the output of how that software actually operates, the behavior of that software. So we kind of understand the model in advance. We run it through. So it's different than, again, the symbolic way of doing it. It's different than predictive analytics, where you're putting in data and then the software is creating the sort of answers. I mean, we have the answers in advance. We're just then representing it based upon the software that you throw into it.
Super. I have a Wendy, if you don't mind, just an observation while listening to the fascinating way that you're explaining this. Gary, and the legacy system issue, in that what you're doing is trying to fix that problem, right? The other alternative is to scrap everything and start fresh. And it struck me that maybe the reason why you'll have a long runway and a bunch of business is because the difference between interpreting what you currently have into a digitized format is a lot cheaper than scrapping all the legacy systems and creating a new.
That's correct. Arthur, that's a really good point. One I should make. We participate in both those scenarios. So if somebody wants to start anew, their problem is that, so for instance, one of our beta customers to start anew, it's a $750 million project, which actually is going to be closer to $1 billion by the time they're done. And that means that they're going to end up with the same system that they have today, just in a more flexible environment. When they're interested in our technology to start anew, because we can analyze how the current system works and tell them how it works, so that when they create the new system, they can write it precisely like the current system. We're not helping them rewrite it in the sense that we're taking code and transforming it. That's something we might do in the future, but right now, and other people kind of do that in the future, but it's not that effective. Most people find that they have to do it by hand. We can give them kind of the roadmap to help them do that. So that's one avenue. Now, for folks that want to maintain that don't want to spend $750 million to transform these systems, you're exactly right. What we help them do is change these systems for a fraction of the cost that they spend today in changing those systems. So those systems are, in essence, new life is breathed into those systems because you now have an expert that understands the system and is available 24/7 by 365. So if somebody leaves the organization today, if you remember that first graph I showed, if somebody leaves the organization, I get more and more red in my application map. Everything's green. Everything is known all the time at any point in time. And so that changes the equation for how much these systems cost to maintain. And we believe that, to your point, more and more, guys, first of all, it's just too expensive to change. But even for folks that, on the margin want to change, when they look at this, they'll say, maybe I don't need to change, or maybe I just need to change part of it. I don't need to change the whole system. And so it's a very, very good point that you raised that I should have said right from the beginning, to be honest with you.
Yeah, well, we don't ascribe to the word should. That's a tough construct.
Yeah,
So
fair enough.
It also strikes me as this is a great way to analyze what for a fraction of the cost, whether you should spend 750 million or $1 billion, and on what. So, I mean, you could be in the, analysis business and still ring the cash register pretty.
That's exactly right. So of the project that's company $750 million, $400+ million of it is analysis. So if we can make that $400 million, $40 million, that's a huge win. Somebody's going to spend $2 million a year on our product just for that.
I will tell you, Gary, I know of 2 multifamily offices. Mm-hmm. I won't name them in a public forum, but one of them has software from the 70s, and they've patched and they've patched and they've patched. And the problem is that now the millennial group wants to be able to access their financial information online. And this old software, it just can't. So now, is that something where this can go in and, instead of having 20 patches all over the system, kind of help them streamline it so they can get where they want to be without scrapping the whole thing, which has some features that clients like?
Yes, exactly what we're talking about. So that process of patching that system is very expensive. And it's expensive for them to change to be more competitive with newer, fintech, options that are out there. What we're saying is that goes away because they will be just as competitive and they will know as much about their system And that's really what the bottleneck is. It's the knowledge about the system. It's not changing the system that's problematic. That's easy. It's getting all the information that I need in advance to be able to make that change. And that's where the bottlenecks are, especially as people have left, and especially as, you know, as the systems are complicated and large. And so that's their disadvantage. And what we're saying is exactly that now they are not disadvantaged anymore. So a large system can be just as nimble as a small system or a newer system.
Fantastic. We have a question from the audience. How many man hours did it take for your team to develop your product?
Oh boy, I should know that. But it started 50, our founder started this 15 years ago. It was a research, the first 10 years were R&D mostly, putting the pieces together. And the last 5 years, we started building this in earnest. We've had a team, we have a team of 25 people working on it, or I should say actually physically working on about 22 people working on it. It's been a long effort. There's a lot of, you know, that's again, good and bad. I don't know the exact number of hours, but it's extensive. And again, you know, we've got patents in some of the areas of things, and quite honestly, the hardest stuff we've kept as trade secrets. So you need the key thing here in order for somebody to be able to do this. You need a multidisciplinary approach. Now, that being said, once somebody's seen that somebody's done it, it's always a lot easier. So we do have some patents, but it's a significant undertaking, very complicated. So for instance, we are redoing part of the logic right now that we thought was going to be good enough for this. We've had to go back and actually do redo two modules in order to be able to make sure that it works with a large enough data set, for instance. Just things like that. It's just there are a lot of gotchas. We're well down the path, and we're in a really good place, but those things happen.
So I kind of interrupted you with questions when you were going to share about the team. Would you mind doing that with the audience?
Sure. So again, I thanks, Wendy. So again, my name's Gary Brach. I've been a serial entrepreneur for the past 25 years, started 4 different companies in the storage space and the fintech space, insurance tech primarily. And as I said at the very beginning, you know, one of the companies that I was with, we interfaced with large insurance companies and provided a way for them to conduct business more efficiently than they currently did. And we had to interface with their systems, and they would tell us how their systems work. We would create the system, modify our system to work that way. It never worked because people never knew how their systems actually worked. If we had a product like, I was intrigued by this, and I invested a good amount of money and have invested a good amount of money in this company because I've seen this problem over and over and over again. Steve Bukovalis is the founder and visionary. He's the real brains behind this. He has worked in advanced AI for folks like for financial services company, Prudential Home Mortgage, banks here in Boston. He moved out to Colorado for lifestyle a number of years ago, and the team is based outside of Denver in Golden, Colorado. He's a brilliant guy and a really earnest, good person, and that's why I invested.
So before you go on to the next guy, I just have to say this. We have to have a chat with Steve because he's bastardized my name. It's Babelis. It's not Bukovalis.
Yeah.
I think he stole my name.
He might have.
Yeah.
He might have.
He's
I don't know.
Greek,
From
right?
a town in Greece. You guys can commiserate.
Well, you know what the Greeks, well, I don't even want to go there, but you understand.
Yes.
So.
Yes. But there's exactly.
Yeah.
But you should talk. And then Steve Brothers really runs the day-to-day operation in Colorado. He's got a lot of experience running high-tech companies. I've been focusing more on the external side of this, raising money, our customers, our prospects, I should say, Steve's working, I'm working hand in hand with Steve on the customer side. And then Steve Bukavalis is working on, on the technology and leading the technology team. And again, we have, I think it's about 25 people in the company right now, 22 actually working on the product. Again, just kind of to summarize, this is a sort of a first best only product. It's a huge market opportunity, not easy to do, really exciting. It's a way to participate in AI in a huge addressable area with some defensibility. It's not the AI market is crowded with a lot of things that are just like everybody else, and it's really hard to figure out what's unique. This is, and I'd encourage folks, if you want to learn more, this is very unique and a very different approach, and very exciting. Again, we have 4 issued patents. It's very hard to get patents in software today. I think that's kind of gives you a sense. We're interested in product actually at the end of this year. Again, because we had a little bit of problem with our logic module, as I said. This is an ARR model. So there's tremendous economics, tremendous unit economics. We believe we can get to cash flow very, very quickly, leveraging the folks that want to resell the product and worldwide. And we have the team to do it. We have a very strong team, very exciting team. The people that are really excited about getting this out into the market and letting people start to use this technology, and because it's just the tip of the iceberg as far as opportunity here.
Gary, thank you so much for being with us today. Would you like to make a final comment as we wrap up?
I just would like to thank everybody for their time. And again, if you are interested in discussing this further, please reach out to me. It's gbrach, GBRACH @phasechange.ai, and I'd be happy to continue the dialogue. Thank you.
Thank you so much. And thank you everybody who joined us today. I'm going to bite Arthur's line and say you gave a very precious thing, which was your time. I know we didn't get, there was 1 or 2 questions still out there, so feel free to email Gary. I think you're willing to answer any questions that go on for, thank you so much. All right, everybody. Thank you again and have a great day.
Thank you, Wendy. Thanks, everyone. Bye-bye.